Let's now talk about problem 4.3 that involves the difference of two averages. And the data this time is unpaired because we have two samples that come out of two different machines, even though we have a sample size of size 60 for both of them. So for this one, the null hypothesis will be that the two means are the same, while the alternative hypothesis will be that the first average is less than the second average. So we now form our t statistic. We have the observed difference of 73.8 minus 76.1. That's the observed difference minus the expected difference of 0 divided by the standard error for the difference. And the standard error for the difference will work out to be 5.2 squared divided by 60 plus 4.1 squared divided by 60. It's a combination of the two different standard errors for the individual averages. So we get a larger standard error for the difference of two things. So the t-value works out to be 73.8 minus 76.1 divided by the square root of 5.2 squared over 60 plus 4.1 squared over 60 for negative 2.69. Now the next step that we need to do after I write down that result is to figure out the number of degrees of freedom. Okay, so for the number of degrees of freedom, let me clear out a little bit of space here so that I have room to write it down. The number of degrees of freedom has the following formula. Degrees of freedom is equal to the first standard deviation, which was 5.2 squared over 60, plus 4.1 squared over 60, whole thing squared, divided by 1 over 59, 60 minus 1, times 5.2 squared over 60 squared, plus 1 over, well, for the other 60, 59, 4.1 squared over 60, whole thing squared. And then we take this and then round down to the nearest integer. So the number of degrees of freedom is equal to 5.2 squared over 60 plus 4.1 squared over 60 squared divided by 1 over 59 times 5.2 squared over 60 squared plus 1 over 59 times 4.1 squared over 60 squared. And when I hit enter, I should get an answer that's somewhere between 60 and 120, and I do get an answer of 111, rounding down to the nearest integer. And so I now get the p-value. So negative 2.6904. And I need the area to the left. And so using the TI calculator or else using Microsoft Excel, we get the t-value, the p-value of this to be 0.0041. Alternatively, this could have been approached by finding the critical value, but we get a p-value of 0.00412. That number is less than the value of alpha, and so our decision is that we reject the null hypothesis. We have reason to think that machine 2 is faster than machine 1.